Hi everyone, it's Mrs. Kardos, and today I'm just going to review some of the notes that we've been taking in class for simple and compound probability. So grab a piece of paper, grab a pencil, grab your calculator if you need it, and meet me back here at the video. So our lesson target today says that students will be able to compute simple and compound probability as demonstrated by the successful completion of practice problems. So again, we're working on simple and compound probability. So let's start with a basic definition of probability. Probability is the likelihood of something happening. So in real life instances where we might consider probability is any sort of game of chance that we might be playing, whether we're playing cards or like blackjack or poker or even Uno, if you can remember how many cards are in the deck, or the lottery, if I'm thinking about what are my chances or the probability that I'm going to win the lottery. So that's one of the ways in which we use probability in the real world. So we talked about this in class, but this is our continuum for probability. So probability is between 0 and 1. Okay, if I write it as a decimal. If I write it as a decimal, a 50% chance, and in the middle, exactly even chance, we would write as 0.5. If I were going to do it as a fraction, I would write it as 1 out of 2. And then you can also see down here at the bottom where we did it in percents. We have 0%, 50% is halfway, and 100% would be completely and totally certain. So let's say I had a 3 out of 4 chance of doing something. That would be 75%, so that would be exactly in the middle. Or if I had, say, a 1 out of 8 chance, that would be 12.5%. So definitely in the unlikely category. So I can write it as a fraction, I can write it as a decimal, or I can write it in percent form. Now, frequently, you are going to hear these words that are on the screen. So let's just review those really quickly, some of your vocabulary. If there is a 0% chance, we say it is impossible. It's definitely not going to happen. If it's absolutely 100% going to happen, we're going to say it's certain. If I have an even chance, we call that equally likely. If it's between 1 and 49, or really 0.001 and 49.999, we call that unlikely. Anything in this area we're going to call unlikely, and anything that's between the 50 and the 100 in the same manner, we would call that likely. So definitely some important vocabulary words for you to know. So let's try a couple of problems. So we're going to start by talking about simple probability. Simple probability means we're talking about one event, just one thing that we're doing. So in this problem it says, what is the probability of flipping a coin one time and it landing on heads? And then here you can see I have a little fraction set up, the favorable outcomes over the possible outcomes. So my favorable outcome would be heads. So I have to ask myself, how many heads are there on a coin? And there's usually just one if it's a fair coin. And then the number of possible outcomes would be 2, because when I flip the coin, it could be heads or tails. So for today, we're just going to write it as a fraction here. But remember, I could also write 0.5, or I could write 50%. So the probability of flipping a coin one time and landing on heads would be 1 out of 2. So we call that equally likely. That's 50% chance. Let's try this problem. It says, what is the probability of rolling the die one time and landing on an even number? An even number. Well, you have to know what an even number is. So an even number would be 2, 4, 6, 8. So if I think about a die, it's a regular 6-sided die. Okay, there are 6 possible outcomes. 3 of them would be even numbers, 2, 4, and 6. Those are my even numbers on the die. So 3 out of my 6 numbers are even numbers. So this is an okay answer, but we always want to make sure that we simplify the fraction, and it simplifies to 1/2. So again, I have an equally likely chance of rolling an even number, a 50% chance. Remember, if I go too fast, you're always welcome to pause the video and go back. And also, if you want to read the problem, try it yourself, and then come back to the video to see how I got the answers, that's perfectly acceptable as well. So for this one, you may want to pause, try it yourself, and then restart the video to see if you have it correct. So again, we're talking about simple probability. It says, what is the probability of rolling the die one time and landing on a 3 or a 4? So remember, I'm only going to roll it once, and I would consider favorable outcomes to be either 3 or 4. So I have 2 favorable outcomes out of 6 numbers on my die. And again, this is an okay answer, but it's better if we simplify it. So 1 out of 3. So it is not very likely that I would roll either a 3 or a 4. It is unlikely. This question says, what is the probability of spinning the wheel once and landing on any blue color? And the reason it says any blue color is because this one's kind of a light blue, this one's kind of a dark blue, and I think these two are purple right here, so we're not going to include those. We're just going to go with the 2 that are light blue and dark blue. So I have 2 favorable outcomes, 2 blue, a light blue and a dark blue, and if you count around the wheel, you will see that there are 12 possible outcomes. So 2 out of 12 would be an okay answer, but a better answer would be 1/6. Okay, now we can see on this title that we've moved on to compound probability. So compound probability is similar, except that now we're going to be talking about more than one event, 2 or more events that we are going to do. So this question says, what is the probability of flipping the coin 2 times and landing on tails both times? All right, so with compound probability, I have 1 favorable outcome of tails on my first flip out of 2. And then on my second flip, I also have a 1 out of 2 chance of getting a tails. So we have to multiply these 2 numbers. And if you can't remember why we multiply, if you remember, think back to the tree diagram that we did, it'll kind of make a little bit more sense about why we're multiplying. But 1 times 1 is 1, 2 times 2 is 4. So it's 50% chance for me to flip it once, but for me to get tails 2 times in a row, it's only a 25% chance, or 1 out of 4. So not very likely that I'm going to flip it and get a tails both times. So remember, we're multiplying. That's the key. Remember, the dot means to multiply. Okay, same type of question, but this time instead of 2 times, we're going to flip it 3 times, and this time we want to get heads on our coin. So first flip, second flip, and the third flip. So the first time I flip it, I have a 1 out of 2. The second time I flip it, I have 1 head off 2 sides, and the third time is the same. But remember, we have to multiply. So 1 times 1 is 1. Now here's where my common mistake happens. Don't write 6. 2 times 2 times 2 is not 6. It is 8. So 1 out of 8. All right, you may want to pause the video and try this one on your own, and then come back to the video to see if you have the correct answer. The question says, what is the probability of rolling the die 3 times and landing on a 5 all 3 times? So we're going to roll it once, we're going to roll it twice, we're going to roll it 3 times. And I only want a 5. That is my only favorable outcome. And this is a regular die with 6 sides. So I have 1 5 out of 6 sides. The second time, my die has not changed. I have 1 out of 6. And the third time, a 1 out of 6. And then we're just going to multiply it straight through. 1 times 1 times 1 is 1. 6 times 6 is 36. Times another 6 would be 216. So this is one of those times when I would tell you to, check with your calculator, just double check, because lots of times kids will write this answer as 3 out of 18 because they add instead of multiplying. So just a common mistake, and you might want to check it with your calculator just to double check that you have the right answer. All right. This one says, what is the probability of rolling the die twice? And I want to get a number greater than 4 both times. So we're going to roll the die twice. So the first time and the second time. And we want a number that is going to be greater than 4. Well, there are only 2 numbers greater than 4. Our favorable outcomes would be a 5 or a 6. So we have 2 favorable outcomes out of 6 sides. Both times we roll it, and that's going to give us a 4 out of 36, which is an okay answer, but the best answer is 1/9 when we simplify it. So I have a 1 out of 9 chance of rolling the die and getting a 5 or a 6, both times. Ooh, this one looks interesting. All right, now we have a coin and we also have a spinner. What is the probability of flipping the coin once and getting heads and then spinning the wheel and landing on a red? All right, so we're going to do the coin and then we're going to do the spin. And I know I'm going to have 2 fractions that I'm going to multiply. Well, the coin, we've done a bunch now. We know we have 1 heads out of 2 sides, and there's only 1 red on our spinner, and there are 12 different little colors. So our final answer would be 1 out of 24, a 1 in 24 chance. All right, let's do a different type of example. It says, what is the probability of pulling a king from the deck of cards, replacing it, and then drawing a king again? And it assumes that you know that there are 52 cards in a deck, okay? So you also have to know how many kings are in a deck of cards. Well, if you've played with cards at all, you know there are 4 kings. So we have 4 favorable outcomes. So we're going to do 2 draws, draw number 1 and draw number 2. So there are 4 kings in the deck out of 52 cards. I'm going to put it back so I still have 52 cards and I still have a 4 kings inside of the stack. So when I multiply, I wind up with this crazy number, 16 over 2,704. There's some simplifying we could have done before to make it a little bit easier, but it actually simplifies down rather nicely to 1 over 169. So not very likely at all that I'm going to draw a king and put it back and then draw another king. All right, you will notice this time it says we're going to keep it. What is the probability of pulling an ace from the deck of cards, keeping it, and then drawing an ace again? All right, so we're going to draw once, and then we're going to draw again. 52 cards in the deck, 4 of them are aces, but I'm going to keep the card, which means I'm not going to put it back. So this time I'm only going to have 3 aces, and I've only got 51 cards in the deck. So this is going to change my odds slightly. And I wind up with 12 over 2,652, which comes out to be 1 out of 221. So the odds are even lower than they were before because now I only have 3 aces in the deck. Ooh, a bag of dice, a bag of dice. Sometimes you'll see marbles in the bag, but for this one we have dice. What is the probability of pulling a green die from the bag, replacing it, and then drawing a red die? So we're going to draw once, and then we're going to draw twice. So the probability that I'm going to draw a green die, well, let's count. Yeah, 1, 2, 3, 4, 5. Okay, there's 5 possible outcomes. Only one of them is green. I'm going to put that one back, and now I want to draw a red die. So since we put it back, we still have 4 dice, but there are 2 reds. So the probability would be 2 out of 25. All right, I think this is our last one. It says, what is the probability of pulling a yellow die from the bag, keeping it, and then drawing a blue die? So again, we're going to be drawing twice. So draw number 1, draw number 2. So yellows, there's 1 yellow out of 5 dice. And then we want to draw a blue die. Uh-oh, trick question. There are no blue die. That's purple right there. So I have a 0 out of 5 chance. And when I multiply, I get 0 out of 25, which is 0%. Okay, it's impossible for me to pull out a blue die. Okay, so it doesn't matter if I get the yellow one on the first time, because there's no chance that I'm going to pull a blue out of the bag. So 0%, totally impossible. All right, so I hope this helped. You guys were able to calculate simple and compound probability. If you have any questions, please feel free to come see me in class. Thanks. Catch you in the next video. Bye.